My name is Mr. Fontenot. I am an industrial instrumentation instructor at Suella Community College in Lake Charles, Louisiana. In this video, we will be covering the topic of span math. And span math is a very important type of math for the industrial instrumentation technician field. And I'm going to show you kind of an overview of the span math formula and how to use the span math formulas, I should say, in this video, and then I'll have some other videos that will show you more problems to work out. So looking here, you'll notice several things on this page, and I am going to want you to memorize these formulas. They're not that difficult to memorize, and I will show you how to memorize those as we go forward. But the first thing I'd like for you to notice here is that we have two separate formulas. So the first formula is in a situation where we are given a percentage and we're trying to find a process variable. What is the percentage of a certain process variable? So you'll use number one formula, and I'm going to show you instances where you would use that here in the next on the next page. But when you're given a formula, you'll use number one. Number two is when you're given a percentage is when you will use formula number one. Number two is when either we're looking for a percentage or we're looking to convert from one value to another. This is when you will use number two. Actually, you can use number two at all times, but number one is a little bit more convenient when you are already provided your percentage. And I'm going to show you that here in just a second. You're going to need to memorize these ranges of numbers. They are a constant. They are the typical values given in industry. If I ever use any numbers other than these ranges for milliamps or PSI, I'll let you know. But for right now, we're just going to assume that these are the ranges and that they're not going to change. And so you're going to need to memorize these because I'm not going to provide them for you on every problem. And I'll show you what I mean here in a minute. For instance, one of our problems, I'm going to ask you to convert 5 PSI to milliamps. I don't give you the milliamp range. I don't give you the PSI range. I want you to know what those ranges are from memory. So when it's time for the test, write these numbers down. Write the formulas down. Then you'll be ready for your test. So the number two formula is a formula that is more commonly used or more widely used for the problems we'll be dealing with. If we look closely at the formulas here, you will see and you will notice that there's a couple of different series of numbers. So if we look here, we'll notice in this one, for instance, we're given a percentage and we are looking for our process variable number two. Notice the number two subscript numbers here behind each one of the values. So we got a number two number here and here and here and here. And the number two numbers, basically what the number two numbers are, let me stick with blue, are the value that I am looking for. That's my number two numbers. The number one numbers, if we look in our second formula here, our number one numbers are the values that I am given. And all this will come much more clear to you as we keep working. But the number one numbers, we'll do those in purple, are the values I'm given. The number two numbers is the value that I'm actually looking for. So if you'll notice this multiplication sign here, let's just imagine in our mind that this multiplication sign is a boundary. Everything on the left of the boundary is what I'm given. Everything on the right of the boundary is what I'm looking for. So over here, I am looking for these numbers, and over here, I'm given these numbers. All right, so let's look at our first example. And the question is 10% of 4 to 20 milliamps. What is 10% of 4 to 20 milliamps? So the first question we have to ask ourselves is, which formula to use? Well, as I said, if you're given a percentage, you're going to use formula number 1. We're going to use formula number 1. So we're going to have our calculator handy. You can use your calculator on all of my tests. So now that we know what formula to use, we got to figure out what numbers to plug in where into our formula. And so we got to keep in mind that process variable number 1, my number 1 numbers are the values I'm given, and my number 2 numbers are the values I'm looking for. So in this case, I'm given a percentage. So we're going to punch that into our calculator. So 10% would be 0.1. 10%. If it was 50%, that'd be 0.5. If it's 1%, that would be 0.01. I'm pretty sure you're familiar with all of that. So 10% is 0.1. Then we're going to hit our multiplication sign. Look at the calculator. We're going to open parentheses, and we're going to put in the values of the numbers that I'm looking for. So what am I looking for? Well, I'm looking for a milliamp. And I'm working on this side of my multiplication sign. So I'm working on my right side of my multiplication sign. So these are the numbers that I'm looking for. So I'm looking for a milliamp. So 4 to 20 milliamps. Let's look at our formula. The first thing I plug in is my upper range value. My upper range value being the 20. 20. Formula says minus my lower range value. What is my lower range value? 4. You're going to close parentheses. Then you're going to hit plus the lower range value again. And the lower range value is 4. 20 minus 4 plus 4. And that gives me an answer of 5.60. What is 10% of 4 to 20 milliamps? It's 5.60 milliamps. What makes these numbers a little bit more complicated is that we are not starting with 0. If we're starting with 0 and we're saying 1 to 100, and what's 10% of 1 to 100? Well, that's 10. But if we start at 4 to 100, what's 10% of 100? That's a little bit more complicated. So that's why we have to bring into play our span math formula. So in this case, I'm given a percentage, no big deal. I just say 0.1 times whatever it is, in this case milliamps. So I know that it's 4 to 20. So my upper range value is 20. My lower range value is 4. Plus my lower range value, which is 4. So what is 10% of 4 to 20 milliamps? 5.60 milliamps. Okay, let's look at another example. Here I've got 25% of 4 to 20 milliamps equals how many milliamps? Well, since I'm given a percentage, we're given a percentage, we can use formula number 1. Percentage times upper range minus lower range plus lower range number 2 gives us our process variable 2. So again, we're going to punch in our first number, which will be 0.25 for 25%, times, open parentheses. Okay, so now I am working on the right side of my equation, which is the values I'm looking for. What am I looking for? I'm looking for a milliamp. So all of these numbers here will be milliamps. So my upper range value number 2 is 20 minus my lower range value, which is 4. Look at the formula. So you close parentheses plus my lower range value of milliamps, because that's what I'm looking for. What is my lower range? It's 4. So 25% of 4 to 20 milliamps is 8 milliamps. All right, let's look at another example. 80% of 3 to 15 psi. Well, since I'm given a percentage, I can use formula number 1. And this time, if you notice, we're looking for psi instead of milliamps. So we got to watch that. We don't want to put the wrong values into our calculator. So it's 80%, that would be 0.8, refer to our formula, times, we're going to open parentheses. My upper range value now is going to be 15, because we're doing psi, minus my lower range value of 3, close parentheses, plus my lower range value of 3, and this tells me that 80% of 3 to 15 PSI is 12.60 PSI. Because now the value I'm looking for is a PSI. So the number two numbers in this case is 3 to 15. That's why we changed our range over here. So it's 12.60 PSI. 12.60 PSI. All right, let's look at another example. In this case, we want to know 6 milliamps is what percentage of 4 to 20 milliamps? Well, now we're not given a percentage. We're looking for a percentage. Percentage is still involved here, but it's not given to us. It's what we're looking for. So since it's not given, we have to use formula number 2. And here's our formula number 2. In this case, we're going to have to remember our ranges. And as I said, I want you to memorize these. So you're going to have to know your standard range of 4 to 20 milliamps and your standard range of 3 to 15 psi. And we want to remember that we have two sets of numbers. We have some numbers that are our number 1 numbers, which are the values I'm given, and our number 2 numbers, which are the values I'm looking for. Also, on these problems, I'm going to want you to show me your work. So on your scratch paper, we're going to write out the formula and we're going to plug the numbers in. So we're going to start by drawing our parentheses, put a line here, multiplication sign, parentheses, and the plus sign. Now remember, everything on this side of my multiplication sign is what I'm given. Everything on this side, which is my number 2 numbers, if you'll notice, are the values I'm looking for. So what value am I given? I'm given 6 milliamps. So it's going to be 6 minus my lower range value. Well, what is the lower range value of milliamps? It's 4. So it's going to be 6 minus 4 over the upper range value minus the lower range value. The upper range value of milliamps is 20. So we will write 20 here minus the lower range value again, which is 4, times, now I'm moving over into what I'm looking for. What value I'm looking for. Well, what am I looking for? Guess what? I'm looking for a percentage. So my maximum percentage is 100%. 100%. Minus my lowest value of the percent range, which would be 0%. Plus my lower range value here of my number 2 numbers, percent, what I'm looking for, which is 0%. Going to give us an answer. All right, let's move over and do our calculator work. First thing, everybody look at the calculator. First thing we're going to do, we're going to open parentheses. Then we're going to hit over under. The first thing we're going to do is put our process variable number 1 in there. Well, the number that we were given, numbers I'm given, the PV1 is 6. The number 1 numbers and the value I was given was number 6. Gave it to me right here, 6. Minus my lower range value of my number 1 numbers, which was given to me, 4 to 20. So my lower would be the 4. You're going to go down. Upper range of my number 1 numbers would be 20 minus my lower range of the numbers given to me, which would be 4. Scroll over, close parentheses, hit your multiplication sign, open parentheses. So now we've moved over to this side, just like right here. And since I'm looking for a percentage, my upper range value of my number 2 numbers is 100, minus my lower range value of my number 2 numbers, which is 0. Close parentheses, plus the lower range value of my number 2 numbers, which is 0. And this gives me a value. If you get a fraction, hit standard to decimal button, and it is 12.5%. 6 milliamps is 12.5% of 4 to 20 milliamps. Okay, 12.50%. 6 milliamps is 12.5% of 4 to 20 milliamps. Okay, let's look at another example. I want to convert 5 psi. If I got 5 psi of pressure in my tubing, how many milliamps would I have? Well, I'm not given a percentage, so obviously I have to use formula number 2. And in this case, you're definitely going to need to know your range for psi and your range for milliamps. We know this is the formula we're using, so now it's just a matter of what to plug into the formula where. We got our multiplication sign here, so we know to the left is the numbers that we are given, and to the right is the numbers that we are looking for. So what am I given? I'm given 5 psi. Over on the calculator, open parentheses, hit over under, and we got a 5 psi that was given to me, 5, minus, what is the lower range value of the psi numbers? 3. Over 15, my upper range value of my number 1 numbers, which are the values I'm given, is 15, minus the lower range numbers, the lower range value of my number 1 numbers I was given a psi, so it's going to be 3. Scroll over, close parentheses, multiplication sign, open. Now it's a matter of the numbers that I'm looking for. My number 2 numbers are the values I'm looking for. So I'm looking for a milliamp. So what is the upper range value of my milliamps? 20. Minus lower range value of my milliamps. 4. Close parentheses, plus 4. And that would give me, hit your S to D, 6.66 repeated, so that'd be 6.67. We're going to go to the second decimal place, 6.67 milliamps. If I have 5 psi, that would equal 6.6 milliamps. One more example here. What is the percentage if I have a range of 0 to 1,000 gallons per minute, 357 gallons per minute? What percent is 357 gallons per minute of 0 to 1,000 gallons per minute? Okay, what percentage is that? So I'm not given a percentage, I'm looking for a percentage. So I'm going to use formula number 2. And I want to remember my values here to distinguish which numbers are which. So I'm going to open my parentheses. I'm going to hit over under. Process variable number 1. Lord, what number is that? Well, remember, the number 1 numbers are the numbers I'm given. What was I given? I was given 357 GPM and the full range of GPM. So the numbers I'm given are these. So PB1 is 357 because here's the range and here's the process variable number 1. This is the number that can change. This number can be anything between 1 and 1,000. But if it was 357 in this case, what would the percentage be? So first number is 357 minus the lower range, which says 0, over 1,000 minus 0, Scroll over, close parentheses, multiplication sign, open parentheses. Now we've moved to the values I'm looking for. What was I looking for? A percentage. So again, it's 100 minus 0, close parentheses, plus 0. So this tells me that it's 35.70%. Pretty cool. So this is an overview of how to use the span math formulas, and see my other videos for more. I'm basically going to work through a whole exercise for you, a whole assignment showing you how to use the span math formula.